Okay, here's our video for our intro lesson to trigonometric identities. Before we do the front of the notes, I actually want to start on the back. And I want to talk about these two problems right here. The directions say for each problem, simplify the expression into a number or one trig function. So looking at this first problem, you'll see that we have two trig functions that are being multiplied together. And our goal is to rewrite it or do some kind of math on it that will simplify this down to one trig function, or maybe just one number. So the way I'm going to do that is realize that cotangent can be rewritten as cosine over sine. And technically of x, but just to save time, I'm not going to write that. And then it's times this first sign. So once we rewrite it like this, and we remember that this first sign is also over 1, so now I'm multiplying two fractions together, and anytime you're multiplying and you have the same numerator and denominator, they cancel, because sine divided by sine is just 1. So then we really have just 1 left, and 1 times cosine is cosine of x. So that is how we simplify it down to one trig function. Similarly, over here for 13, we can rewrite tangent as sine over cosine, and then multiplying it by this cosine that's in front. We have a cosine on top and a cosine on bottom. They cancel, and I'm just left with sine of x. Now, in these two problems, we don't have any way to rewrite so that we can simplify it down to one trig function, at least not in anything that we have talked about so far. So that's what the front of the notes are for, to give us some new functions or identities that we can substitute for these things and then simplify down to a number or one trig function. Okay, so we're going to put these on hold and talk about the notes. So what the point of these notes is to derive or construct or discover some identities that we can use to substitute in when we're simplifying expressions or solving equations. So we're going to start with this triangle here. It's like the triangles we drew in our unit circle when we were trying to come up with sine and cosine values, our x and y coordinates on the unit circle, because this would be my radius of 1, and then my x distance and my sine distance, or my x and my y, or cosine and sine. Number 2 tells us to set up a Pythagorean theorem for this triangle to the left. So we're used to seeing that like this. It's the sum of the square of the sides equals the hypotenuse squared. So my sides are cosine and sine, so I'm going to square them. So cosine squared x plus sine squared x equals the hypotenuse squared, 1 squared, which is just 1. So from here we have this new statement that is true. Oh, sorry, cosine squared of x. So if we take any angle, we find the cosine of it and square it. We find the sine of it and square it and add those things together, we would get 1. And then we can use this to generate other identities that will help us simplify these problems. So like, for example, let's just go back here on the back to 14. Now that I know this, that cosine squared plus sine squared equals 1, I can finish simplifying this problem. Here's my cosine squared plus my sine squared. This whole thing equals 1, so I can replace it with 1. Because things that are equal are substitutable. You can substitute one for the other. So this entire expression equals 1, so I can replace it with 1. So now I have 1 over cosine squared theta, and I know that 1 over cosine can be rewritten as secant. So 1 over cosine squared is the same as secant squared theta. So now I have taken this original problem and simplified it to one trig function. So let's go finish the rest of the front. Number 3 says, using that answer from number 2, solve for sine squared. So that means getting sine squared all by itself. So all I have to do is move this cosine squared over by subtracting it from the left and subtracting it from the right. So minus cosine squared from the left and the right, and that's going to give me sine squared x equals 1 minus cosine squared x. So now this left side and this right side are equivalent, and they can substitute for each other. Number 4 says to do that same thing, but now solve for cosine squared. So now I'm going to subtract sine squared from both sides. Subtract it from the left, subtract it from the right. That leaves me cosine squared x equals 1 minus sine squared x. Now we're going to see what happens when we take that original identity from number 2 and divide everything by cosine squared x. So here's my original. I'm going to divide everything by cosine squared x. Now this first term, something divided by itself, simplifies to 1. Sine squared over cosine squared, well, sine over cosine is tangent. So sine squared over cosine squared is tangent squared. And then 1 over cosine squared can be rewritten as secant squared. So now I have this new identity that I got just from dividing cosine squared by everything here. It just created a new equation. And now this left side and this right side are interchangeable. And 6 says, using that answer from number 5, solve for tangent squared. So I need tangent squared by itself. I'm just going to take this 1 and subtract it to both sides. So minus 1 from the left, minus 1 from the right. And I have tangent squared x equals secant squared x minus 1. Now, going back to number 5, let's see what it would look like if we solve for the 1. We set it equal to 1, so get 1 by itself. So I'm going to subtract tangent squared from both sides of that equation. And that gives me 1 equals secant squared x minus tangent squared x. Number 8 says, using the answer from number 2, so that means going back to this original identity, divide everything by sine squared x. So it's like what we did here, but this time instead of dividing by cosine squared, we're going to divide everything by sine squared and see what that looks like. So this first term, cosine over sine, is cotangent, and it's going to be squared, so that simplifies to, or rewrites as cotangent squared. Sine squared divided by itself simplifies to 1. And then 1 over sine squared can be rewritten as cosecant squared x. So now we have this new identity where the left side and the right side are interchangeable. And then on 9, using the answer from 8, solve for cotangent squared. So if I want cotangent squared by itself, I just need to subtract 1 from both sides. So minus 1 from the left, minus 1 from the right of the equation. That leaves me cotangent squared x equals cosecant squared x minus 1. And then number 10, going back to this answer from number 8, set it equal to 1. So that means subtracting cotangent squared x from both sides. So that's going to give me 1 equals cosecant squared x minus cotangent squared x. So those are all the identities that we constructed or discovered for ourselves. And then we have this chart that I passed out with all of the identities on there. So we have our ratios that we talked about in previous units, and now we have these Pythagorean identities down here. So now we will use those to finish this last problem. Now, one thing I want you to know about this last problem, there's several different ways to begin it and work it. So the way that I'm about to show you might not be the way your partner would work it. It might not even be the way I decide to do it tomorrow if I was given the same problem. I might see some other way of doing it. All right, so I'm going to start by rewriting anything that I can rewrite. So sine doesn't rewrite, but I can rewrite cosecant as 1 over sine. And I'm going to drop the thetas just for speed in writing, but just imagine that the thetas are still there. And I'm going to rewrite cotangent as 1 over tan over tan. So now I have fractions divided by something else. And when you have, this is called a complex fraction, when you have that, you want to keep, change, flip, or multiply by the reciprocal. Keep the top the same, change division to multiplication, and flip the bottom value. So keep the top the same, 1 over sine, change this division right here to multiplication, and flip the bottom. So instead of sine, I'm going to have 1 over sine. Okay, and now multiplying fractions across the top and bottom gives me 1 over sine squared minus. Now I'm going to do the same thing with the tans. So 1 over tan times the reciprocal of the denominator, which was tan. So taking the reciprocal of that is 1 over tan. And multiplying across the top and bottom gives me 1 over tangent squared. So now I'm subtracting two fractions. And in order to do that, I need a common denominator. And there's different ways that you can do this. Here's just one way. What I'm going to do is realize that, so I'm going to take this right here and go on this little side quest for just a second, a tangent as it were. And I'm going to remember that 1 over tangent squared is the same as cotangent squared, which is the same as cosine squared over sine squared. So I'm going to rewrite this in this form. So now I have 1 over sine squared minus cosine squared over sine squared. Now that my fractions have common denominators, I'm going to combine them into one fraction with that denominator. So my numerators are 1 minus cosine squared. The denominator matches. And now I remember 1 minus cosine squared, we derived or constructed on the front that 1 minus cosine squared is equal to sine squared. So this right side is equal to this left side, so I can replace them with each other. So I can replace all of this numerator now with sine squared x. And on the bottom I have sine squared, or I guess it was theta. Either way, something divided by itself is equal to 1. So I simplified the entire expression to one number.